Today we're going to talk about systems of equations, and specifically solving a system of equations by graphing. Remember that a system of equations is a group of equations, two or more, that have the same coordinate pair as a solution set. Let's take a look at what we mean. I have two equations. I'm going to call them a system of equations, which means that the solution to these two equations are the values x, y that make both of these equations true statements. In order to solve this system by graphing, I need to graph the two equations and look for the point of intersection. That will give me the value x, y that will make both of these equations true statements. Notice that the green equation is in slope-intercept form, so I want to graph it using that form of equation. So I start by graphing the point 0, 4. In order to do that, I have to have a scale on my graph. So I need to label the scale on my graph. So I'm going to count by ones. So this would be the point 0, 1, and this would be the point 0, 2. I also want to label my x-axis. So this would be the point -1, 0, and this is the point -2, 0. Now I know that I'm counting by ones. So I can graph my point 0, 4. Then I use that point and my slope of 2 to graph a second point. Oftentimes we think that when we start at our y-intercept, we have to count up for our slope, but we can also count down. If I count down 2, however, and I have a slope that is positive, I have to count to the right, to the left, in this case 1. So I'm going to put a point here at -1, 2. That's the second point in my graph. Notice that when I draw my line, it will be a positive slope because it will rise from left to right. Once I plot my 2 points, I want to use a straight edge to graph my line. This way, I can be sure that I have a line that is straight and accurate. I want my lines to be as accurate as possible because remember, I'm looking for the point where my 2 lines intersect. So I graphed my green line, y equals 2x plus 4. Now I need to graph my red line, y equals x plus 2. I'm going to go through the same procedure. So I graph my y-intercept of 0, 2. I have a slope of 1 because there is no coefficient in front of x, so I know that 1 can be written there. That means that from my y-intercept, I can go up 1 and to the right 1, or I could go down 1 and to the left 1. Remember that you don't need both lines on your graph. However, sometimes it's easier to graph a line if you have several points. So I'm going to graph my red line too. Remember, I use a straight edge because I want my lines to be as accurate as possible. Remember that we said that the point of intersection of the lines in our system gives us the solution to our system. In this case, the solution to our system is -2, 0. I can check that point in my 2 graphs to make sure that it makes my statement true. So I substitute 0 equals 2 times -2 plus 4 into my green equation. So I get 0 equals -4 plus 4, which means 0 equals 0. This is a true statement. So the point -2, 0 does make my green equation true. Let's try it in the red line. Does 0 equal -2 plus 2? Well, does 0 equal 0? It does. So the point -2, 0 is also a solution to my red equation. So it is a solution to both equations in my system, and it is a solution to my system. When we have a system of equations that produces exactly one solution, we call that system consistent and independent. Let's look at a second example. I have the graph, or the line, y equals negative x minus 3, and the line y equals negative x plus 5. There are two equations in my system. I'm going to graph both equations. So I start with the green one. Notice, though, I don't have any labeling on my graph, so I need to do that. And I'm going to count this time by threes. So this would be 3, 6, negative 3, negative 6. This allows me now to graph my equation. So I start at my intercept, 0, negative 3. And I notice that my slope is negative 1. So I go up 1 and over 1. That's a little bit difficult to find. So what if I go up 3 and over 3? That's a little bit easier to graph. Remember that 3 over 3 is the same as 1, and this will be negative because it falls from left to right. Now I simply need to position my ruler so that I can draw my line. I want to do this carefully. I'm going to take my time to line it up correctly. And now I draw my line through my points. I need to now do the red equation. So I need to find the point 0, 5 on my graph. That's going to be a little difficult, but I think it's probably right about here. Because this would be 3, so about 1/3 would be 4, 2/3 would be 5, and 3/3, or the next line up, is 6. Now again, my slope is negative 1. If I go up 1, I had to go over 1, which will be right about there, I think, or close to it. Again, when you're counting like this, it makes it a little bit more difficult to graph your line. So you might want to try a few other points too along the way, just to see if you can get your line as accurate as possible. And take your time. You draw your line. Now I've graphed both my red and my green equation. I've used a slope of negative 1 both times. Well, that means that the slope for my first equation is negative 1. And the slope for my second equation is also negative 1. What do you remember about equations of lines that have the same slope? Hopefully you said that they are parallel. And what you need to understand is that parallel lines never, ever intersect. If these two lines won't intersect, there can't be a solution to the system of equations. We call this system an inconsistent system. Any equations that have the exact same slope will be parallel. They will never intersect, so there will never be a solution to this equation. So inconsistent systems have no solution. And that's what we would say about this system. There is no solution. Our lines are parallel. The last example has a system of two equations, y equals 3x plus 3 and 3y equals 9x plus 9. We need to graph the two equations and find the point of intersection. So we start with labeling our graphs. So again, I'm going to count by threes, and I'm going to label some of the points on my graph. Now I'm going to graph my green line. I have a y-intercept of 3, so I graph the point, 0, 3, and I have a slope of 3. That means I go up 3 and over 1. Now I want to make sure that I'm fairly accurate here, so maybe I want to go up 3 this way. So I go up 1, 2, 3, and over 1 this way. Now if you notice, what I really did was I went up 9 and over 3. But if I go up 9 and over 3, that's the same thing as going up 3 and over 1. So my points are a little bit further apart, that actually helps us draw a more accurate line. So I position my ruler as accurately as possible. Remember, you're always trying for accuracy. Better to go a little slow and be accurate than to go too fast and not be accurate at all. So now I've drawn my green line. Now I need to draw my red line. So again, I'm going to start with my y-intercept, but wait, I don't know what my y-intercept is. So I'm going to find it. I'm going to replace x with 0. So I have 3y equals 9 times 0 plus 9, or 3y equals 9. That means that y equals 3. So I can plot the point 0, 3. Now I also want to find my x-intercept. So I say 3y, or 3 times 0, because my x-intercept occurs at the point where y equals 0. So 3 times 0 equals 9x plus 9. 3 times 0 is 0, so subtract 9. Negative 9 equals 9x. Divide by 9, negative 1 equals x. So I graph the point negative 1, 0. That should be an x. That would be right about here. Now, hopefully you notice something kind of odd here. When I graph the line, notice it's the same line I graphed before. Now some of you might be saying, yeah, you already saw that. If I started here and just divided everything by 3, I would have had the same line. Y equals 3x plus 3. What I want you to notice is that you can draw the same line, write the equation for the same line in several different ways. This is 2 ways to write the exact same equation of a line. They just look like different equations. When we have a set like this, we say there are infinitely many solutions to this set. In other words, every point on this line is a solution to this system of equations that we were given. And we call this consistent and dependent. So this is a consistent and dependent system of equations that has an infinite number of solutions. Take the time to go back through the video. Make sure that you understand the differences between consistent and dependent, consistent and independent, and inconsistent systems of equations. Make sure you also understand that the solution set to a system of equations is the coordinate pair that makes all equations in the system true statements.